Lamai, good afternoon. Right, පුතේ අපි last week එකේදී discuss කරා මේ activity series එක ගැන. About the activity series. Now 16th unit we need to discuss about the activity series of metals, right? Now in this activity series created, or the activity series is the series which obtained by the arrangement of metals in the decreasing order of their reactivity. Decreasing order of their reactivity. Reactivity එක අඩු වෙන පිළිවෙලට. Right? හදලා තියෙන arrangement එකට අපි කියනවා activity series. What we call the activity series. Now in this activity series පුතේ, in this activity series we have potassium, sodium, calcium, magnesium, and then place where hydrogen. ඊට පස්සේ තව තියෙනවා set එකක්. ඊට පස්සේ එනවා hydrogen. And after that you have copper, mercury, silver, platinum, and gold. But now according to this activity series, the highest reactivity you guys can observe with the potassium. Highest reactivity you can observe with the potassium, while the lowest reactivity you can observe with the gold. While the lowest with the gold. අඩුම තියෙන gold වල වැඩිම reactivity එක තියෙන පුතේ potassium වල. Right? I think reactivity series එක දැනගෙන ඉන්න ඕනි අපි. Right? Okay. But now today we will discuss about the අපි අද කතා කරමු users of the activity series. ලියා ගන්න පුතේ topic එකක් users of the activity series. Write this topic users of the activity series. Users of the activity series. Right, Puthe, the first thing now by using this activity series, we can predict about the reactions. We can predict the reactions. We can predict the results. We can predict whether this reaction will occur or not. මේ reaction එක වෙයිද, වෙනවා නම් කොච්චර fast වෙයිද? අන්න ඒ වගේ දේවල් අපිට imagine කරන්න පුළුවන්. We can predict those things correctly by considering the arrangement of these metals. Arrangement of these metals. Right. Okay, Puthe. Now these are very highly reactive metals now, like sodium, potassium. These are very highly reactive metals. They just react even with the water. So therefore, these should be stored inside some special containers which contain some inert liquids, right? So Puthe, now as an example now need to store this potassium, sodium in kerosene in order to limit the reaction, in order to stop the reaction between other components. Okay, right. So we will write for the liagan first point taker. Write this first point. Write this first point. To find methods that prevent corrosion, to find methods that prevent corrosion corrosion එක නවත්තන්න ඕනි වෙන methods ටිකක් අපිට හොයා ගන්න පුළුවන්. කොහොමද? Right. But now basically the cheapest method, cheapest metal එකක් තමයි පුතේ අපි දන්න iron කියන්නේ. Iron is much cheaper than the other. So now what about the location of the iron here? The location of the iron here, මම මේකත් complete කරන්න. What about the location of the iron? Now here you have the aluminium, zinc, iron, tin and the lead, no? And the lead. Now iron තියෙන්නේ මෙන්න මේ වගේ position එකකනේ. Iron තියෙන්නේ ඔය වගේ position එක. Now just imagine you need to protect this iron bar. You need to protect this iron bar from corrosion. You need to protect this iron bar from the corrosion. Right. So easily, very easily, you guys can introduce much more reactive metal here. මේකට ටිකක් reactive metal එකක් මම මේ වගේ contact කරලා තියෙනවා. Much more reactive metal like magnesium. This may be magnesium or zinc. Magnesium or zinc. Now what will happen? Pute? Now due to its reactivity, I mean the magnesium and zinc, due to their higher reactivity, what will happen? Our iron piece or the iron bar will remains while rusting, or the corrosion may result with this magnesium or zinc. Okay, got it? හරි. ඒ කියන්නේ පුතේ දැන් මේ iron එක corrode වෙනවට, iron එක corrosion වලට corrode වෙනවට අපිට පුළුවන් මෙයාට වඩා reactivity වැටි metal එකක්. Metal with very higher reactivity, zinc මේ උඩ තියෙන metal එකක් connect කරන්න මෙයාට. Then what will happen? Then can save our iron. Right. Write this. ලියා ගන්න පුතේ මෙහෙම. Keeping iron structure in contact with 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 much reactive metals like magnesium or zinc, we can prevent the rusting of iron. Iron rusting නවත්ත ගන්න පුළුවන්. We can prevent the rusting of iron. Right. We can prevent the rusting of iron. Second one. Second one but now it just helped to This activity series helps to make electrochemical cells. Why? Now, by using this activity series, we can select what metals should use, what metals or what solution should use in order to prepare chemical cells, electrochemical cells. Api ඊළඟ අවුරුද්දේ ඉගෙන ගන්නවා about electrochemical cells. So we need to select some metals and some liquids, some solutions. So while selecting such, we can get help from, right, පුතේ ලියා ගන්න මෙහෙම. It helps to select, 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 it helps to select metals for electrochemical cells, metals for electrochemical cells. Electrochemical cells. Right. And then Puti, now by looking at these by looking at this arrangement, we can assign, or we can select which method to use in order to extract these things. That means Puti, now each of these metals we need to extract from our earth now. Our earth now, these are metals now, so we need to extract them from our earth. So we need to practice, we need to practice different methods depending on their reactivity. So by looking at this, even we can decide which method to be used in order to extract them from our earth or the soil. Okay, write this. To decide the suitable method, for metal extraction, for the metal extraction. Right, okay. Right, Lamai. Okay, now we'll try to learn about iron extraction. Now look at the place where this iron placed in activity series. With the activity series again, iron කියන එක තියෙන්නේ hydrogen වලට ටිකක් උඩින්. Not that much active. But in order to extract this iron, we need to use ore. අපිට ore එකක් use කරන්න ඕනේ. එහෙම නැත්නම් අපි blast furnace එකක් use කරන්න ඕනේ in order to obtain this. We need to provide very huge amount of heat, and then only we can separate out different components. we can separate out different components. So let's try. අපි මේක try කරලා බලමු කොහොමද කරන්න කියලා. Right. පුතේ write this topic. Write this topic. Extraction of iron. Extraction of iron. And then draw this diagram. Draw this diagram. Write the topic extraction of iron and then draw this diagram. Right. Will you draw this diagram? Hurry up and draw. Hurry up, huh? ඉක්මන් කරලා draw කරගන්න. Put hurry up. Now you can, Lamai, the main component containing iron in this iron ore is hematite. Hematite කියන්නේ මොනවාද? Fe2O3. Hematite, Fe2O3. What we call hematite. Fe2O3. Hurry up, tag again. So what I call the structure, blast furnace. Okay, it can withstand very huge temperature. ලොකු temperature එකක් මේක withstand කරන්න පුළුවන්. Right. But the temperature of this blast furnace is about 1000 degrees Celsius to 1900 degrees Celsius. එකත් note කරගන්න. 1000 degrees Celsius to 1900 degrees Celsius. Very huge. Very huge amount of heat. So we need to add this limestone, coke and hematite in correct proportions. In correct proportions in order to obtain iron. Hurry up, Lamai. With the finish, draw ka liver nang kiyan continue කරමු. Finish drawing. Right, then I'll explain. Hari, lamai me බලන්නකෝ. මේක තමයි අපි කියන්නේ blast furnace එකක් කියලා. The specialty here now, it can withstand very high temperature. Now 1000 or 1900 degrees Celsius means it's very high now. Right. So first of all, you need to add limestone, coke and hematite mixed in correct proportions and finely powdered. හොඳට powder කරලා අපි මෙන්න මෙතනින් add කරනවා. Okay, you can add it. So we can adjust this adjuster and then this will release to this blast furnace. So now here the temperature is about 1000 to 1900 degrees Celsius, and what will happen here, we have a hot air blast here and molten iron in this phase, molten iron in this phase. So all the waste gases were released from this place, and then stage sorry, not the stage out, slag out from here, and the molten iron comes out from this place. Molten iron comes out from this place. Methane molten iron tika eliyata enawa. So it's very not that much complex, but need to provide huge amount of energy in order to extract iron, this iron. So the molten iron, we can cool it down, and then we can have this iron solid. But then now special kind of bricks were used. Fire brick, අපි කියනවා ගිනි ගඩොල් කියලා. ගිනි ගඩොල් use කරලා තිනවා fire bricks. So these fire bricks were used in order to make this structure. So fire bricks withstand to very high, huge temperatures. Right. Okay, Pati. Then we will write. You better write these equations. So then we can explain, we can identify the reaction procedure. Reaction series එක ලියාගමු. Number 1, burning coke. This will form carbon dioxide. All the others are solids. Then the formation of carbon monoxide. Now what will happen, this carbon dioxide gas just react with carbon and form two carbon monoxide gases, gas molecules. Then the formation of iron. Hematite Fe2O3 just reacts with carbon monoxide, and then this will result iron and carbon dioxide gas. මෙතනදී iron liquid state එකේ තියෙන්නේ පුතේ. Number 4, formation of calcium oxide. Calcium oxide this is the formation of calcium oxide. හරිය පුතේ මේක ලියා ගන්න. මම ඊට පස්සේ ඔයාලට කියලා දෙන්නම් කොහොමද මේ ස්ලැග් එක හැදෙන්නේ කියලා. ස්ලැග් එක හැදෙන්නේ කොහොමද කියලා කියලා දෙන්න. මම ඊට ස්ලැග් එක ගැන වෙනම කියලා දෙන්න. You better write these equations one by one. හරි අප ළමයි. හරි අපුතේ. Right, that's it. පුතේ මාත් එක්ක තව එකපාරක් මේක බලා ගන්න. Look at this. This is a reaction series of making iron, right, inside a blast furnace. So the temperature of this blast furnace is about 1000 degrees Celsius to 1900 degrees Celsius. So first of all, you need to add limestone, coke and hematite in the correct proportions and in powder form, well powder form. So now what will happen? Now with this high temperature, first of all the coke burning will result. So here carbon or the coke reacts with oxygen and forms carbon dioxide. Then the formation of carbon monoxide. So what will happen here? You have carbon dioxide and again it just combine with the coke, then results two carbon monoxide molecules. Then the formation of iron will result with the reaction of hematite and the carbon monoxide. Fe2O3 means hematite. Here one of the ingredient here. So now you can observe iron and carbon dioxide again. Then finally the formation of calcium oxalate, calcium oxide calcium carbonate dissociate into calcium oxide and carbon dioxide due to high temperature, so that's the reaction series here. Okay, now පුතේ අපිට මෙතන ඉතුරු වෙලා තියෙනවා ස්ලැග් එකක් ඉතුරු වෙලා තියෙනවා. අපි බලමු මොකද්ද මේ ස්ලැග් කියන්නේ කියලා. let's see. මේ බලන්නකෝ දරුවෝ. ළමයි, now here we have a silicon dioxide and what else? Aluminium oxide, Al2O3 aluminium oxide as impurities. මේකේ තියෙනවා impurities විදිහට මේ silicon dioxide and aluminium oxide. So what will happen? Silicon dioxide will react with calcium oxide and result calcium silicate CaSiO3 and Al2O3 or the aluminium oxide reacts with calcium oxide. When the calcium oxide reacts with this calcium oxide and aluminium calcium aluminate will result. Calcium aluminate will result, and this is what we call slag. We need to remove this. අපි මේක අයින් කරන්න ඕනේ. ඕක ඔතනින් අයින් කරන්න ඕනේ. හරි? ඒක නිසා තමයි අපි slag out එකක් වෙනම දාලා තියෙන්නේ. පුතේ write this topic. Write this topic. Formation of slag. Formation of slag. Formation of slag. Right, Pute, write these two equations. Hurry up, Pute. Okay, done. හරිද වැඩේ? Okay, right. හරි. වැඩේ හරි. පුතේ මෙහෙම ලියා ගන්න. Write this. Write this. Write this. Slag results due to slag results due to slag results due to the presence of slag results due to the presence of results due to the presence of due to the presence of silicon dioxide silicon dioxide silicon dioxide silicon dioxide and aluminium oxide and aluminium oxide and aluminium oxide and aluminium oxide as a result of aluminum oxide as impurities as impurities as impurities as impurities right හරිද පුතේ as impurities හරිනේ වැඩේ එහෙනම් right අපි ඕවා තමයි remove කරගන්නේ impurities විදිහට තියෙන right then write this topic ළමයි topic එකට කලින් මෙන්න මේක ලියා ගන්න the slag floats on molten iron මේ මම දාලා තියෙන්නේ the slag floats on molten iron slag එක iron එකට පාවෙනවා so therefore you need to release or remove it before mixing with molten iron අර molten iron එක mix කරගන්න නැතුව අපි release කරගන්න කලින් molten iron slag එක remove කරන්න ඕනේ so therefore we have slag out path at the top right we'll write the slag floats on molten iron the slag falls on molten iron the slag falls on molten iron slag falls on molten iron therefore molten iron therefore we can easily separate Therefore, we can easily separate. Therefore, we can easily separate we can easily separate slag from molten iron. Slag from molten iron. Okay, hari. ඔන්න ඒ කතාවත් ඉවරයි. Right. Okay, then write this topic. Extraction of gold. Extraction of gold. Extraction of gold. Write this topic. ඉතින් ඔයාලා දකින්නටි gold තියෙන්නේ activity series එකේ ගොඩක්ම පල්ලෙහායි. gold තියෙන්නේ activity series එකේ ගොඩක්ම පල්ලෙහායිනේ තිබුණේ මේ යටම තිබුණේ gold. Therefore, the reactivity of gold with other substances, or I mean, other environmental substances, is very low. එහෙනම් එයා react වෙන්නේ නැහැ. React වෙන්නේ නැති නිසා තමයි. That's why it is very expensive, and that's why we are using in jewelries. Right? Jewelries වල use කරන්නේ ඒකයි. Okay? Now just imagine gold react වෙනවා water එක්ක. අපි ඕවා කනේ කරේ බෙල්ලේ දාන් ඉන්නවද? නෑනේ. So due to that less reactivity, that's the reason, and it's luster. එයාගේ හරිම දිලිසෙන ගතියක් තියෙනවනේ luster. So that's the reason. Right. So therefore it's not needed. It's not required to separate it out using some special methods. So even the gold, I think the density of the gold is also very high. The density of the gold also very high. So therefore no point of making it, no point of no point of using any other special methods. So easily we can separate it out. අපිට ඒක easily separate out කරගන්න පුළුවන්. Right? Okay. Put write this topic, extraction of gold. Extraction of gold. Okay, we'll write. We'll write gold, which is placed at the bottom of the activity series, which is placed at the bottom of the activity series, which is placed at the bottom of the activity series, which is placed at the bottom of the activity series, does not react with any active component any active component at normal atmospheric conditions. At normal atmospheric conditions. පුතේ දැන් මෙහෙමයි. gold heat කරලා pressurize කරලා එහෙම කරොත් වෙන්න පුළුවන්. normal conditions වල possible නෑ. Full stop. Full stop. As a result of that, as a result of that, gold occurs as native metal. Native metal in nature. Native metal in nature. Native metal in nature. Native metal in nature. Full stop. Full stop. But to remove any impurities, පුතේ දැන් gold තිබ්බට gold තියෙන්නේ ඔය soil එක mix වෙලානේ. ඉතින් ඒව අයින් කරගන්න හැටිත් තියෙන්න එපා. Right? Right? But to remove any impurities, we can use simple physical techniques. Simple physical techniques like sifting, like SIFT, like sifting, like sifting. Thanks to its higher density. Thanks to its higher density. Right, that's it. Okay, then write next topic. අපිට අන්තිමට කතා කරන්න තියෙන පුතේ gases ගැන නේද? Yes. gases ටික කතා කරමු. එතනින් වැඩේ ඉවරයි. මේ lesson එක ඉවරයි. Write this topic. Gases, their preparation and properties. Gases, their preparations and properties. පුතේ ඉස්සෙල්ලාම ලියන්න හයිඩ්‍රජන් ගැන. පුතේ අපි ඉස්සෙල්ලාම preparation method එක ගැන කතා කරමු. in order to prepare the hydrogen gas, පුතේ අපිට hydrogen gas එක හදාගන්න පුළුවන් ගෙදරදිත්. කොහමද? මොකටද සර් ගෙදරදී හදන්නේ? ඇට්මොස්ෆියර් එකේ තියෙනනේ හයිඩ්‍රජන්. අපිට මොකද? yes අපිට වැඩක් නැහැ තමයි හයිඩ්‍රජන්. right මක් කියනවා. ඕනි නම් මෙන්න මේ වගේ simple method එකක් use කරලා by using a very simple method like this we can prepare right. මොනවද පුතේ මම දාලා තියෙන්නේ? මෙතන තියෙනවා පුතේ dilute hydrochloric acid. Dilute hydrochloric acid here. Here some zinc granules. Here the conical flask. Here the cork. Chisel funnel. Here what we call delivery tube. And then this is the rubber tube. Need to use another rubber tube. Then hydrogen gas here. Gas jar. Trout. Beehive shelf. Right. පුතේ ඔයාලා මේක draw කරගන්න. මම කියලා දෙන්නම් කොහොමද වැඩේ වෙන්නේ කියලා. Hurry up. I'll give few minutes. Hurry up ඉක්මන් කරන්න. Nicely draw කරගන්න. මම කියලා දෙන්නම් වැඩේ වෙන්නේ කොහොමද කියලා. Very important. ඕකේ ළමයි right හරින වැඩේ මෙන්න මේ බලා ගන්න පොඩි දෙයක් ඉන්නේ මේ අහගන්නකෝ පුතේ මේකේ තියෙනවා මෙයාගේ තියෙනවා දාලා මොනවාද මෙන්න මෙතන dilute hydrochloric acid HCl aqueous තියෙනවා dilute hydrochloric acid and also some zinc granules zinc කියන්නේ හොඳ reactive වෙන කෙනෙක්නේ එයක් තියෙනවා මේකට අපි add කරලා granules නිසා මම solid දැම්මා here aqueous mean diluted diluted right then now what will happen දැන් මොකද වෙන්නේ පුතේ මේ දෙන්න react වුනහම form වෙනවා zinc chloride ZnCl2 plus H2 මේක gas එකක් මේක liquid එකක් this will result right okay look at this put make it should be solid right look at this dilute hydrochloric acid reacts with zinc and this will produce hydrogen and zinc chloride. Now zinc chloride remains here but what will happen to the hydrogen gas will pass through this path and the rubber tube then and then enters to this beehive shape and then collected in this gas jar. මේ gas jar එකේ collect වෙනවා මෙන්න මේ විදිහට. So you can collect this hydrogen gas. You can collect this hydrogen gas and use for whatever you need. Right? So this is the simple experiment. Simple procedure in order to generate hydrogen gas. හරි? ලියා ගන්න පුතේ. Chemical reaction කියලා මේක ලියා ගන්න. This is the chemical reaction. This is the chemical reaction. Hurry up and write. This is the chemical reaction. Hurry up, Pute. Hurry up. Okay. ළමයි අපි ඊළඟට බලමු මොනවද properties of hydrogen gas. පුතේ properties තමයි මෙන්න මේ වගේ. දැන් hydrogen කියන්නේ හරිම light weight එකක් තියෙන gas එකක්. Light weighted gas. The density of the hydrogen gas is much more lower than that of the normal air. මතක තියාගන්න මම මේවා ලියන්න කියනවා තව ටිකකින්. Much more lower than the normal air. Right? And පුතේ එයා හැම වෙලේම ඉන්නේ අර H2 gas එක විදිහට. ඒ කියන්නේ hydrogen තනියම ඉන්නේ නෑනේ. එයා H2 molecule එක මේක තමයි අපි hydrogen gas කියලා කියන්නේ. Hydrogen molecule එක කියලා කියන්නේ. And also its relative molecular mass is 2. එයාගේ relative molecular mass එක 2. And it's colorless, odorless. පාටකුත් නෑ, ගඳක් සුවඳකුත් නෑ. Colorless, odorless. කවුද? Hydrogen. කවුද hydrogen? right? And also hydrogen is slightly soluble in water. But the hydrogen dissolve, water, but slightly, not like other gases. Not like other gases, it's slightly soluble in water. Not like oxygen, right? So it's a combustible gas. But the hydrogen, apita combust karanna puluwan, puchanna puluwan. It's a combustible gas, right? Okay. Put write this subtopic: physical and chemical properties of hydrogen gas. Physical and chemical properties of hydrogen gas. Physical and chemical properties of hydrogen gas, and then you better write 5 such properties. At least 5. Book ekේ තියෙනවා. I'll give 2 minutes. Hurry up. Okay guys, now අපි ඒක list out කරානේ. හරි. මොනවාද එන්න ඕනි? Density එක අඩුයි less than the normal layer, and what about the colorless, odorless, and also පාටක් නැහැ, සුවඳක් ගඳක් ඉන්නෙත් නැහැ, and then slightly soluble in water. Slightly, පොඩ්ඩයි, right? And then it's a kind of combustible gas. kind of combustible gas, or even you can write the atomic number, relative molecular mass is 2. Relative molecular mass is 2. Right. That's it. Right now, okay, now what we call this method, මෙන්න මේකට අපි කියනවා මේ විදිහට gas එකක් collect කරන එකට අපි කියනවා down displacement method. Down displacement of water. Down displacement of water. Because when the gas enters to the gas jar, the water in it is pushed down. පුතේ මේකට gas එක ඇතුල් වෙන්න මොකද වෙන්නේ? වතුර ටික එළියට යනවා. වතුර ටික පල්ලට එනවා. Pushed down. The gas coming from the delivery tube can also be collected by keeping a gas jar or even a balloon. මේක මම fix කරනවා balloon එකකට. So now what will happen? Now that balloon will fill, right? Balloon will inflate. Balloon will inflate with what? Hydrogen gas. Balloon will inflate with hydrogen gas. ගෙදරදී hydrogen හදාගන්න ඕන නම් මොනවාද ඕනේ අපිට? dilute hydrochloric and some zinc granules. That's all. Then you can make hydrogen gas. You can prepare hydrogen gas. Right. So Putin, now since the density of this hydrogen gas is much more lower than the normal air, balloon filled with hydrogen gas, what will happen? This will මොකද වෙන්නේ? Yes. මොනවා වේද යට? එයා ඔන්න අපි ඉන්ෆ්ලේට් කරොත් එහෙම එයා බැලුන් එක උඩ යන්න පුළුවන්. Yes. බැලුන් එක පාවෙන්න පුළුවන්. Right. Okay. But we'll write. The above method of collecting gas using a collecting gas using a gas jar and water, using a gas jar and water, using gas jar and water, using gas jar and water is called downward displacement of water. Is called downward displacement of water. Is called downward displacement of water. Downward displacement of water. Full stop. Downward displacement of water. Full stop. Right. පුතේ මෙහෙම ලියා ගන්න. Write this question. What are the uses of hydrogen gas? What are the uses of hydrogen gas? What are the uses of hydrogen gas? Right. Now, ඉතින් මේ hydrogen කියන gas එක very good fuel එකක්. හරිම හොඳ fuel එකක්. අපි use කරනවා මේ fuel එක. මොනවටද? ගොඩක් use කරන්නේ දරුවෝ අපි මේ aircraft එහෙම නැත්නම් rockets වලට rocket fuel එකක් විදියට. Use as a rocket fuel. And also in order to reduction of organic compounds in order to reduce organic compounds. Then production of margarine. අපි margarine හදනවනේ from vegetable oil, margarine. Production of margarine from vegetable oil. Also we use hydrogen gas. Then production of ammonia gas, NH3, ammonia gas by reacting with nitrogen. So we can react this hydrogen with nitrogen, and then what will happen? We can produce ammonia. So the importance of ammonia is that we use ammonia in order to produce fertilizers. In order to produce fertilizers, අපි use කරනවා fertilizers හදන්න ammonia. Okay, got it? Right. Put write the answer. ලියා ගන්න answer එක. ලියා ගන්න පුතේ answer එක. Write the answer. Hurry up. Hurry up, what are the uses of hydrogen gas? Hurry up, Pute. right පුතේ okay then හරි පුතේ අපි ඊළඟට move වෙමු දරුවෝ මේ oxygen වලට හරි oxygen ගමුකෝ now when compared with the hydrogen the density of oxygen is much more higher oxygen වල density එකයි hydrogen වලයි බැලුවොත් පුතේ oxygen වල density එක වැඩි the density is higher than that of the normal air even එහෙමනම් normal air වලටත් වඩා oxygen වල density එක වැඩි වෙනවා oxygen වල density එක normal air වලටත් වඩා වැඩි so the reactive molecule so the it's a kind of reactive molecule why it's just reactive metals and it forms oxides so when we consider the abundance කොච්චරක් තියෙනවද කියලා පුතේ nearly around 20% nearly around the 20% of our atmospheric air contain oxygen එහෙනම් ටිකක් වැඩිපුර තියෙන ගෑස් එකක් නේද yes ටිකක් වැඩිපුර තියෙන ගෑස් එකක් මේ oxygen gas එක කියන්නේ okay right so then what about the solubility in water පුතේ soluble it's a good no I think it's kind of slightly but I think in order to survive aquatic organisms there should be oxygen no aquatic organisms la survive වෙන්න එතන oxygen තියෙන්න එපයි නැත්නම් කොහොමද යාලා respirate කරන්නේ so therefore මේ oxygen also dissolve in water but in not much greater manner but up to certain extent in water it dissolves right and then it's very good support of combustion gini ganna udav karana ekak gini ganna hondata udav karanawa support of combustion right and colorless and odorless gas color ekakut naha odor ekakut nathi gas ekak right okay then puthe some reactions we need to discuss about some reactions which results with which associate with oxygen මේ oxygen එක associate වෙන reactions ටිකක් අපි බලමු reactions ටිකක් බලමු which associate with the oxygen right number one first one heating with potassium permanganate what will happen potassium permanganate KMnO4 potassium permanganate heating potassium permanganate heating solid potassium permanganate what will happen solid potassium permanganate will result so you need to balance this one බලන්න balance ද කියලා දෙපැත්තම yes okay number 2 heating potassium nitrate so what will happen puthe potassium nitrate KNO3 අපි heat කරනවා potassium nitrate now what will happen මෙයාගෙනුත් extract වෙනවා oxygen release වෙනවා release වෙලා ඔන්න අපිට oxygen gas එක මෙතනනුත් හම්බ වෙනවා next one third one decomposition of hydrogen peroxide. H2O2 කියන්නේ පුතේ hydrogen peroxide. So what will happen to the hydrogen peroxide? Water to water plus oxygen gas. Now look, each of these reactions results oxygen gas. With a potassium chlorine, heating of potassium chlorate, what will happen? KClO3 heat karnawa, then this will result to KCl plus 3O2, right? Okay, look at these equations. Balanna meyo puthe balan. So it's very simple. Now these are decomposition reactions. Make a decomposition ekak මෙයා බලන්නකො මෙයා decomposition එකක් එක්කන ඉන්නේ heat කරාම එයාලා වෙන් වෙලා යනවා ගැලවිලා යනවා decomposition reaction while heating, while just supplying some amount of heat, we can separate out the components. Hurry up and write ලියන්න මේක hurry up. Hurry up and write these reactions. පුතේ ඉක්මනට copy කරගන්න. Hurry up. Hurry up ළමයි ඉක්මන් කරමු. Finished? Right, that's enough නේ. අතින time එක right. Okay. ටක් ගාලා කරමු. හරි ළමයි. Now next we need to liberate some oxygen by using some reactions. So we have many different reactions like this. මේ වගේ reactions ගොඩක් තියෙනවා අපිට oxygen ගන්න පුළුවන්. Oxygen liberate කරගන්න පුළුවන්. But අපි select කරමු easiest reaction එක. Easiest reaction. So පුතේ we can we can use some potassium permanganate crystals.